that answer, right? So Emmett shoots the bullet straight across. At the same time, Anna drops the bullet. Which one hits the ground first? Well, they hit at the same time. Why do they hit at the same time? Well, because their y motion is the same. One element of the y motion is the same. They got the same initial y velocity, which is 0. They drop from the same height at the same time, and they accelerate at the same rate vertically. Yeah, I should probably put it there. 9.8 meters per second per second. Because, hey, couldn't we envision a situation where they don't actually hit at the same time? Like, think about this, right? Like, you know, what if these two things one's thrown and one's shot, but they're from a different height, right? Are they going to hit at the same time? No, right? What if one's shot straight across and this one is thrown down? Are they going to hit at the same time? No. What if this one's released and then this one's thrown? Are they going to hit at the same time? No. So we talked about that idea. Remember, if we're fully going to explain stuff, we have to hit all aspects and leave nothing to chance. Okay? So our little lesson today is going to be on this idea of horizontal projectiles. We'll focus on the one that got shot across. That's a horizontal projectile. So a horizontal projectile is a projectile that has only an initial horizontal speed. So if we take a cannon and we shoot that cannon horizontally, then it's got an initial velocity of 20 meters per second. But it's important to understand that that initial velocity is oriented in the horizontal. Okay? Now listen, I put this thing out on Schoology. I'm a huge believer that stuff you actually write down gets into your brain better than stuff that you just stare at on the computer. Right? But at the same time, in the back of your mind, understand that you can supplement what you've got going on here by going back tonight and taking a look at it. So don't get so caught up in copying this down that you don't pay any attention to what we're talking about. Okay? So, listen, X motion and Y motion are independent, which means we have to treat them separately. Which means we have to organize them separately. So anytime you have stuff going on horizontal and stuff going on vertical, you should keep them separate, not mix them. It's like, what's Romeo and Juliet? When Montagues and the Capulets, is that what they are? Right? So what do we know about this situation? We know that there is an initial velocity in the x of 20 meters per second. Now look at the diagram. What's the horizontal speed the entire trip? 20 meters per second. Does that make sense based on what you saw yesterday in the graphs that you built and what we talked about? I would say 100%. What other quantity can we put over here in the x based on the fact that the velocity horizontally stays at 20 meters per second the entire time? Chelsea. Awesome. The x acceleration is 0. Now, what can we put in the y information? What can we put in the y information? Evan. Yeah. Is the cannon, does it have an initial velocity? Yeah. But none of it is directed in the y plane. Based on the numbers up here, what can we put for the y acceleration? Negative 9.8 meters per second per second. Now, we've talked about the idea that sometimes you can put positive and sometimes you can put negative. And who chooses that? We do, right? But I stole this picture, and this particular person chose to put negative as down. Now, how do we know that they chose to put negative as down? John?
Because their acceleration is negative?
And how do we know that they don't write that the acceleration is negative? From this picture, how do you know that, Johnny? You're right, but from this picture, how do you know?
Well, their velocities are negative.
Their velocities are negative, and the y velocities are pointed downwards, which means they've said down is negative, which means the acceleration's got to be negative in the y. If this picture would have put plus, 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 then my acceleration would have been plus. Who decides that? We do. All right? I would have made these positive numbers. This person chose to make them negative. It can work either way. Now, yesterday we did some video analysis. And that video analysis essentially marked a particular point every, whatever, 10th of a second. That's here. Here's the path of that ball. There it is. There's the path. That's what you would have done yesterday. Here's the path of the horizontal one, or the vertical one, rather. Now, what do we notice? Not only does the bullet that Emmett shot straight across and the bullet that Anna dropped, not only do they hit the ground at the same time, but more importantly, because they've started at the same height, because they'll accelerate at the same rate vertically, because their initial vertical velocity is the same, and because the time frame that they're in the air, or the time frame that they were shot or dropped is the same, their vertical motion is the same. So they don't just hit the ground at the same time. At any particular location, they have the same height. So it's not like this one starts out vertically really, really fast, and this one starts out vertically really, really slow, and they catch up. Every single instant, they're at exactly the same height. Now, these dots up here basically trace the horizontal motion of this projectile. If there was no gravity, what would happen? It would just go straight across. What do you notice about the spacing of the straight across? Yeah, they're equal distance. Miriam, why does that make sense?
Because it's not, the object isn't speeding up or accelerating at all.
The object's not speeding up or slowing down. These dots are going to be at even intervals because the horizontal speed is constant. And overall, it's important for us to understand that we've got X motion, we've got Y motion. They happen at the same time, but they are separate. The horizontal motion is constant motion, but the vertical motion is an accelerated frame of reference. So we've got constant or uniform motion happening horizontally. At the same time, we've got vertical motion that is accelerated. And conceptually, those are the ideas. They happen at the same time, but they're separate. And we treat them separate. Now, mathematically, when we are faced with a mathematical situation, it's important for us to understand that all these equations in the X apply and all the equations in the Y apply. Anytime we're looking to solve a problem in the vertical plane, we're going to use our set of equations in the Y with all the information in the Y. Anytime we're looking to solve for something horizontally, we're going to look at all of our equations in the horizontal, along with our information in the horizontal. So we've got to keep that information separate. So sometimes we're given info in the X, and sometimes we're given info in the Y, and oftentimes we're given info in both of those things. Now it's important for us to keep it separated. Carolyn, do me a favor and read that for me.
How long will it take a rock thrown horizontally from a height of 25 meters to the ground?
So we're talking about a rock being thrown horizontally, and the question is asking us for the amount of time. Well, first off, what do we know about the time for Emmett's bullet shot horizontally and Anna's bullet dropped to hit the ground? Same time. So let's get rid of Emmett, because that could be, well, no. Let's get rid of Emmett's bullet, right? Because that could be a little confusing because it's getting shot. Let's focus on Anna's, right? Because everybody, I think, can get this question, right? So here's Anna, right? Instead of dropping a bullet, maybe she's dropping a marker, and she drops the marker, and it takes a certain amount of time to hit the ground. Well, how can we change the amount of time that it takes Anna's bullet to hit the ground? Carol.
You could like throw something instead of just dropping it.
Boom! She could give it an initial velocity. Great. That initial velocity would have to be going down or up. If she gave it an initial velocity horizontally, would that affect the time in the air? No, Janie, how come? Awesome answer. Great answer. Anything else she could do? Miriam.
You could lower the distance from the ground.
She could lower the distance or raise the distance. If she wanted to shrink the time, she would lower the distance. If she wanted to increase the time, she would raise the distance. Notice that both of those solutions involve changing things in which plane?
Vertical.
The vertical. Your time, when we are talking about projectiles, right? Now, by definition, a projectile is a thing that's traveling through the air under only the influence of gravity. So like this thing is not a projectile right now. It's a projectile now. Not anymore. Now. Not only when it's only under the influence of the force of gravity. So the time in the air for a projectile is determined by Y info, right? So the stuff happening vertically is what will determine how long the thing is in the air. As Carolyn said, we could throw that thing up in the air or down and change the time. And as Miriam says, we could change the height that we drop it or throw it from, and that would also change the time. Now, time shows up over here in the X, and sometimes we could calculate the time based on info in the X, but the time of flight is determined by what happens in the Y. So it would make sense for us, if we're trying to find the time, to focus on Y information first. Again, we could calculate in the X, but it's determined by what happens in the Y. So what information do we know? Yeah. The Y acceleration is 9.8 meters per second per second. We can work with that. What direction has Anna declared as down? Dang. As positive. Down. Because she put a plus 9.8, she's telling us, hey, down is positive. If Anna had said the acceleration due to gravity is negative 9.8, could we work with that as well? Yeah. Then the downward direction would be negative. I like it as positive, provided there's only downward motion, and that's the case here. There's only downward motion in the vertical plane. Okay? Anything else we know? The Pico. Go ahead. Y is 25 meters. Okay, now when you say Y is 25 meters, what do you mean by that? Okay, so delta Y is 25 meters. So what must, in the Pika situation, right? The Pika is saying delta Y is 25 meters. I like that as well, right? Delta Y is 25 meters. Delta Y is 25 meters. So if the Pika were making a number line vertically, she'd be saying that up here, before it's dropped, is Y equals 0. And down here, at the bottom, is Y equals 25. First period, the kid said, okay, up here is Y equals 25. That's a height of 25. And down here, then, is Y equals 0. Could we work with that? What would have to change if we worked with that? Acceleration would be a negative number. Again, I prefer, just like the Pika said, to do this. Now my delta Y is 25 meters. Love it. Hesney, you had your hand up as well.
Oh God, velocity for y is 0.
The initial y velocity is 0. Love it. Chelsea, you had your hand up. Did they take your answer? Okay. Any other info we got? Hey, what's the initial? Oh, Ryan? What are you gonna say, buddy?
I was going to say y sub 0 equals 0.
Yeah, we could. Again, like we could say y sub 0 equals 0, and then y sub final is 25, and that would play right into this equation, which we're going to need. I'm going to show you how that's the same as saying delta y is 25. All right. Notice the object is thrown horizontally. So is there an initial x speed? Yes. Did I put what that is? No. Can anybody think about why I didn't put what it is? Anna, give it a whirl. It's separate from the vertical, number one. Charles? It wasn't given to us, but I made this up, so I could have given it to you. Why didn't I? And it is constant. John?
You wouldn't really be able to do anything with it.
It doesn't matter. If all I'm asking for is the time, I could have given you a horizontal velocity of 50 meters per second. Would that affect the time? No. 2 meters per second, would that matter? No. So it's not there because I wanted to stress to you that it doesn't matter. And if I did put it there, maybe with the first problem it would confuse you. The next problem it might say, hey, we threw it horizontally 50 meters per second. How long is it in the air? It won't matter. Right? Now, with projectiles, I will tell you that more often than not, we're going to work with these bottom equations. Not always, but more often than not. Y equals y sub 0 plus v initial y times t plus 1/2 ay t squared. So we've got to work to get an expression that says t equals. We got to do our algebra. And we got to have an understanding of what's going on in order to do that algebra. Okay? What's the value of the initial y velocity? 0. So what happens to this whole term? It goes away. So let's rewrite that equation. Y equals y sub 0 plus 1/2 ay t squared. Now, if Jason had his way, we might have numbers for y and y sub 0 listed. And he could do that. But we don't, because I forgot who it was. Maybe Hasmin correctly gave us delta y equals 25. Where's my delta y equals 25 person? Topeka. That's totally correct. But we have an initial and a final. Well, how do you get delta y? Delta y is final minus initial. So final minus initial equals 1/2 ay t squared. This is delta y equals 1/2 ay t squared. Now remember, you could rewrite that equation as delta y equals v initial y t plus 1/2 ay t squared all the time. It's the same thing. These two things are the same thing. Okay, what are we trying to find? T. We're in business because we're trying to find that. We know that that is 9.8 and we know that is 25. So how many unknowns do we have in this expression? 1. Are we always good to go when we have one unknown? Yeah, we're good. Now we're going to solve this algebraically. How do I get rid of the half? Times 2. So 2 delta y. How do I get rid of the ay? Divided. How do I get rid of the square? Square rooted equals t. There's my expression for t. That is likely to be the answer on an AP question. We put numbers on there to make it easier. But we don't want to substitute those numbers till we have this expression. So it's 2 times 25 is 50, divided by 9.8, that's roughly 5, right? Because 50 divided by 10 is 5. The answer is approximately the square root of 5. But it's important for us to separate what's happening in the x and the y, have an understanding of which plane we're trying to solve for, and then evaluate the situation from there. Now, if you look, Look at question number 2 on your sheet. There's a bunch of info. Blah, 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 blah. Soccer ball, blah, blah, blah. Well, who wants to talk about that? Nobody wants to talk about that. Blah, blah, blah. Right? Then it says determine the initial horizontal velocity. Well, if it talks about determining the initial horizontal velocity, would we want to start with a bunch of information in the y? Where would we want to start? We would want to start in the x. Hey, might we have to go to the y to figure some stuff out? Yeah, that's what we'll get into a little bit tomorrow with another couple examples. So tomorrow we probably got 2 examples. Then maybe a little bit more of a little lesson, right? And then you're going to have much time to work on this, your lab, and then there'll probably be a few questions out of your textbook as well. Okay? All under the guise, the most important idea, what happens in the x is independent from what happens in the y. Excellent job, everybody.